introduction to machine learning. So this meetup is a special one. It's not heavily for cybersecurity, but in order to use machine learning for cybersecurity, I need to make sure that people are familiar with machine learning. And I see that there is no meetup that teaches machine learning. So that's why I decided to give at least one lecture for machine learning just for an introduction. So the content of this course is gathered from these resources, and especially the Coursera. I think Andrew NG, how many people know him? Andrew. So he is the god in machine learning. Let me put it this way. So he's the teacher of machine learning courses. It's available on Coursera. If you guys really want to know what's going on behind the scene, the technical details, the mathematical analysis of machine learning, I strongly advise you to take that course. And also that medium, the first one. So I think Andrew Getke, his name. So he is one of the good one again. He has a lot of good stuff on his personal Medium page. So you can also read that resource. It's really good to starting, but I will also compile these resources for you guys so you can get the idea quickly. So how many people are familiar with machine learning? How many people write a code, at least do a data analysis for machine learning before? Can I see hands? Only few. Okay, so we're in good shape up to now. So we're going to introduce to machine learning, what it look like, what it stands for, and also we will deal with a little bit details. But at the end of this course, we will do a lot of cool stuff. And I think this could be a little bit heavy for starting point, but at least you can get the idea. I will record the session. I will put it on YouTube so you can take a look at them multiple times. I also share the source codes and also samples that I'm using so you can play around with that. And we're going to use the Jupyter notebook, so that's also a good places to start. So what's the machine learning? First of all, machine learning is not people think that machine learning is some magic. No, it's a mathematical statistical analysis. So behind the scene, you will see a lot of mathematical formulas going on, and that's what we call machine learning. But it has a formal definition too. Machine learning is the experience of E with respect to some task, and also to measure some performance. So for example, what we call is, actually maybe I can show the example. So imagine we have digits in our hands, it's handwriting, and we need to get the actual number of this handwriting. So the experience is the handwritings. So the performance is how accurate you can see that that's a number and the right number, and the task is identifying that number. So that's what we are trying to measure. The experience, depending on some experience, doing some task and measuring some performance, okay? That's machine learning. And also it's same for emails. So emails is the experience, looking at some emails, a lot of emails, some of them spam, some of them are not, and then doing some mathematical analysis on these spam or normal emails, and then come up with a result that's spam or not spam. That is the task, and your performance is how accurate you are measuring an email, it's a spam or not, right? So that is called the machine learning. So good example usually machine learning is the prediction of a house price. So I want you to spend a few seconds on this table and tell me the price of the last lane. Okay, take a look at that and tell me the approximate price of the last row. Okay, so let me get the idea. So how much? Any ideas? So there is no true or false. You can come up with a number.
225,000?
Huh?
225.
225. Why?
I looked at the first line and the second to the last about 2,000 square feet. The delta between 250 and 150.
Excellent. So that's not the correct answer, but the way he is approaching is the right way. So that's actually called machine learning. Just like us, when we look at something like this, we usually do what we analyze and we compare with others, right? And we see that, hey, okay, square feet, number of bedrooms, okay, this one goes with 250 and this one is for 150. Okay, this is supposed to be somewhere around 200, whatever, right? So, but this is only three different features, right? Bedroom, square feet, and neighborhood. And it's really complicated for us to come up with the real number, right? Because it's coding and also approximating these numbers may be challenging. And imagine a real house like a Zillow, a website like Zillow. They are trying to estimate a house price with 200 different features. What are we going to do? Can we do it? Can we use our brain? No, it's not possible. We can't do that. But we can use the same intuition to predict the house price. So that's actually the machines can do a better job than us. They are not thinking that, okay, let me see. It's not acting like that. But when we generate good model for them, it can estimate the right price for us. So if you are a hardcore developer, you may see that, okay, I can do that. No problem at all, I know the numbers, I see the numbers, I can write it in a nice Python code with some approximation like square feet. Let's assume that the square feet is this number. And also, if you have some bedrooms, in that case, I can estimate the some number. So we can write a code something like this. But the actual number, if you are a geek enough, you can come up with a real, decimal point accurate numbers to estimate the right price. But this is, you can do for only few features. But if you are talking about 200 features, that's almost impossible to do that. So what machine can do for us? So this is the math behind the machine learning. So imagine, look at this graphics first, okay? So this is our estimation graphic, right? So we are coming up with some numbers right here, number of bedrooms, square feet, and neighbors. This is actually a linear line, right? So that is our approximation, right? So assume that we just come up with some numbers. It doesn't have to be true, but what we are doing is we're comparing this result with the actual result, and we're measuring the cost. See these yellow lines? They are the actual cost. So you're estimating some number here, but the actual cost is somewhere here, okay? So we're calculating all these costs and coming up with some number, right? So this J of theta is the cost function to estimate how accurate you are predicting at the house price. If this slope wasn't that look like, and if it was something a little bit close to these numbers, maybe you can come up with another J of theta, right? So that's the idea. You can generate a lot, and it doesn't have to be a linear line. Maybe I can use a polynomial graphics, right? Maybe I can use a x squared, x cubed, right? I can draw another graphic, something like this. It might be pretty accurate. So in that case, I will have another J of theta. So what we are doing is, behind the scene, we are calculating all the possible J of thetas. This is your J of theta space. And we are trying to find out the most, least cost J of theta. And your slope now is somewhere here, right? It's not the lowest number, but it's somewhere here. So the machine is doing this for you. Let me change it to x squared, let me change it to x cubed or whatever, and then trying to estimate this number for you so it can find the local minimum or maybe the global minimum for you, so you can find the right mathematical formula for your house estimation. So this part is the math behind the machine learning. It's actually, machine learning is heavily included in linear algebra and calculus. That's if you would like to be a real machine learning guy, you have to be really good in matrix, linear algebra, matrix stuff, and also you have to be really good in calculus. Okay, so of course we are not going to deal with all these details, but I just want to give you some idea. So luckily this part is taken care by a lot of algorithms, and I'm going to show that so you don't have to necessarily deal with these things. Okay, so feel just relax. So what are we going to use? We're going to use Python, of course. If you are taking the course from Coursera, Andrew is teaching with Octal. Octal is also a famous data science tool, but it has less features than Python, of course. That's why we prefer to use Python, and it's well developed and it's really common. And also we're going to use all-in-one platform that's called Anaconda. So in machine learning, we're going to use a lot of libraries, and that's really hard to set up. It's a really big pain to set up a machine learning environment. That's why we prefer to use Anaconda. Even if you use Anaconda, you still need to, install a lot of libraries, but at least it's a good starting point. And normal Python development may not be enough for machine learning because you need to see the result of some line of code just after you run it. So for example, let me show that what I'm talking about, then you can get the idea. So this is going to be the one that I'm going to show you this meetup. So for example, I would like to draw a graphic, something like this, but I want to see the result just right here after this one, because maybe I can change this thing because I am really working on really small numbers, really details. So I need to see the results right in here so I can estimate it. So if you were using a traditional coding something like this, of course you can do this here, but you need to run in console and then get the result. Oh, it's not what I'm talking about. Let me change it again and do it again. So that's not a good idea, and you're going to waste a lot of power if you are using the traditional way. That's why Jupyter is the good one. And the very good starting point also is Kaggle. How many people know Kaggle? Okay, good. So Kaggle is the home of data science and machine learning, and I agree on that because it has a lot of competitions, a lot of tutorials, and you can really get started with that. So here, for example, let me see. Do I have an internet connection? Yeah, there we go. So in Kaggle, you will see that there are a lot of people are sharing a lot of stuff, and also there are some competitions. If you would like to make money, for example, you can see that on Kaggle passenger screening algorithm challenge. It's been by Department of Homeland Security, I think. Yeah, it has $1.5 million price. And Zillow also have another one. As you can see, the house estimation, it is a complicated process, and they are willing to give you 1.2 million if you can come up with a really good model. But of course, you don't necessarily jump into these world class things. You can start from the very beginning ones, Titanic, and also house prices. This is a regression algorithm, so it's a little bit complicated, but this one is classification. So we're going to use the Titanic. There is a good reason for that. For the machine learning algorithm, regression is kind of an estimation. So for example, estimating a house price, whether it's a 200,000 or 100 or 1 million, it's a regression. So you're just approximating to some number. But instead, we're trying to predict whether something is true or false. That's classification problem. That's easier with respect to regression problems. That's why we're going to use machine learning, Titanic. But in the second part, we're going to use the regression, but it's a special case. We're going to use some face detection things, and you will see that we can easily identify some faces, and also we can do it in real time. It's going to be a cool demo. So, okay, so this is a good starting point, and if you click on that, not only they are sharing the data and all those things, they also have some tutorials here. And as I said, they have Jupyter notebooks here. That Jupyter notebooks is really easy to use because all you need to do is download the notebook to your computer and run it with your Anaconda environment, and I'm going to show it to you in a few seconds. So they are showing the comments here and also data, the code segments here. And again, some of the outputs here. It's pretty straightforward to learn. That's a really, really good place. And also, if you accept the challenge, you can solve the problem, submit your prediction, and measure yourself how good you're doing, right? So that's a really good starting point. And actually, in the past, it wasn't exist. I spent, I don't know, maybe weeks to learn even a very basic things. So this thing helps a lot. Okay, so that's that. Let me see. Where were we? Yeah, Kaggle, and also we've talked about that. And I would like to introduce you with a little bit Juniper and then do some machine learning things. So first of all, let's start with Anaconda. Nice all-in-one platform for different environments, so Windows, macOS, Linux, wherever you want. If you guys are a Windows guy, so things are a little bit complicated. If you're a Mac, a little bit less difficult, but this one is easier. So, but I'm gonna use this one because it requires a lot of computational resources. I can't afford to a virtual machine to consume that amount of resource from my host computer. That's why I'm using this one. So yeah, that is Contium. And if you download Anaconda, you will see something like this. So this is a really one-stop shop. It includes notebooks, Jupyter notebooks. You don't have to install, and also Iron Python, Spider. So if you would like to install these guys, also you can install just one click. So you don't necessarily use pip install and all those complicated commands. And also it provides you a project section here. Sorry, environment section here. So you can choose your favorite package here to install. For example, if you need, I don't know, a package that is called, for example, Pillow here, you can just choose that and then say install. That's that easy. It's really helpful. And if you would like to update, you can just select your package and update. That's also easier. And this one is also a really good one. So for example, you would like to run this Anaconda environment on some console, you can just click on root and open terminal. It's going to open you an environment with all these packages are available. So you don't necessarily deal with all the command line things to find out the right Python environment, especially you are dealing with virtual environments. How many people are using virtual environment for Python? Okay, so you know how painful is that, right? To separate things and all those things. But you have the virtual environment here, and also you can use your IPython or normal Python here. But you don't necessarily come to here, just on home, click on launch here. It is going to open a window, something like this. It is already open for me, and let me show that. Yep, right here. So this one is the when you click on that, is this actually this one is extra. You don't forget about that section, but it is showing a line here and saying that hey, your Jupyter notebook is available at this location. Copy this one and paste it to your browser, your favorite browser, which is either Firefox or Google Chrome, right? So in this section, you will see that there are multiple directories. So it is reading your directory structure, and you can navigate to your favorite, location to start your project. So for example, mine is under my document folder, and here we have the machine learning. And if you guys are created Jupyter notebooks, you will see that IPY and B files. That's actually IPython notebooks, I think. So these are the notebooks. You can click on that. It will bring you the corresponding window. But if you don't have any, no problem. Just click on here, new, and Python 3. Okay, it will open you a new window. Okay, right here we have a new window. All the packages are available. Okay, that's that easy. That's pretty straightforward. So this is actually a Python environment, so you can easily run your Python codes here. 2 plus 3 is equal to 5. Yep. Mm-hmm. Yes, definitely you need to move to Python 3 because Python 2.7 is being deprecated and a lot of libraries are not available for Python 2.7 anymore. So yeah, you should definitely move to that. Actually, I'm coming from 2.7, but I recently updated myself to 3.6 because a lot of packages are not available. And some of them have security problems too. So this is Python environment. You can import your favorite library. So for example, let's say CV2, which is what we're going to use. This is how you can import your libraries. And if you would like to do some, stuff here. So for example, print my name, and then yeah, there we go. We have the code. Oh, I made some mistake here. I want to change this. Let's change it to, let's say, norm shields, leave it advertisement. So yeah, you can modify your code. So of course, we are not going to spend time for this ad hoc things, but we're going to jump into real analysis. So these are the stuff that you don't need. You can delete the cells if you don't want to keep that here. Okay, and let me get rid of this one too. Okay, and also you can add some notes here. For example, this is, oops, it wasn't that. this is just comment. Okay, and I don't want this to be a comment, command. Instead, I'm going to change the type of this one to markdown. So it is a comment now. So let's run this, and it is a comment, so you can start your typing. So you can put a lot of comments to your stuff. That's why actually on this section here, you see that there are a lot of comments here and some code sections here. That's how you can manage your Python comments, and you don't necessarily put a lot of comments in your inline comments to your stuff, and also you can take advantage of markdowns. That's that easy. So now let's do some good stuff here. First of all, we're going to analyze the Titanic Titanic problem. So let's take a look at the problem first. So as you know, Titanic was a ship sink. A lot of people died, unfortunately. And the problem is they are providing you some information about Titanic. So train.csv includes approximately 800 or maybe 900 people. They are died in this event, and tests are also the same. Some of them died, some of them survived. Also shows your available for your cross validation. The aim is you need to submit your solution to here to find out the prediction of the rest of the survivors, or maybe the people who died in this event. So that is the challenge, and so there are some explanations here. So the data section, actually let me show the data to you so you guys can get a better idea. So this is the training. I mean, this is test. Let's open training. Yeah, training. Passenger ID, survive or not, 0 or 1. P class is the class of this passenger, and the name of the passenger, and also the gender, age. I think this one sibling, and suppose how many children and or either suppose they have. Parent, children, ticket, fare, how much do they pay for that, which cabin they were in, and also which embark they were in to survive. And as you can see, some of the data are not available, some of them are none, some of them are available. As you can see here again, these are the important things because you need to know your data structure to analyze that. That's why we're going to spend a little bit time to make this thing, analyzable. So first of all, if you are dealing with machine learning, you cannot just use this thing to analyze. Okay, machine learning, as you remember, is a mathematical problem. You need numbers other than the text. Text doesn't make any sense to machine learning. So of course there are some natural language processing things, but this prediction algorithm requires numbers, so you need to come up with the numbers. So what can we do? That is the part of this meetup course. So this is the code. I will share it with you guys. I think I shared the Juniper notebook with you. So let's start with some of the important ones. Speed ML. This one was I was telling you guys to. It really helps you a lot to start the machine learning, because machine learning includes a lot of libraries. So if you are going to deal with the NumPy, pandas at the very beginning, it's going to be painful. So if you import the speedml, it's going to give you a warning. That's why I have another line of command. If you don't want to see these warnings, you can just get rid of them by putting this at the end. By the way, I am pressing Shift Enter to run this cell. Okay, that's the shortcut. So as again, this time it is imported, but no warning. Okay, so it keeps you clean. No output, because this is just an import. No output is presented to console. That's why you're not seeing anything here. So what we need to do is we need to import this training data and also test data. SpeedML has a good function. It's the name of the library. It imports training data, test data, and also what's your target and what's the unique identifier. When you say that it imports the data for you, classify that this is the training data, this is the test data, and my target is to predict the survive. And this is the unique identifier that helps me to index the data. Okay. So at this point, you can say this. So for example, by the way, tab is available on Jupyter. So if you press tab twice, it's going to complete it for you. So I want to get the first 5 row of this training data. As you can see, it's exactly the same. Survived, P class, name, sex, age, all those things, right? So if you would like to get the 10 rows, you can put the number here so you can get the 10 rows, right? So that's the beauty of Jupyter, because I don't necessarily run the script from the very beginning. All libraries already imported, and here is my data. I am going to work on this data, regularly. So, and first of all, when you imported your data, you need to know what kind of a data is this, and this is why the shape is really important. Train data includes 891 rows, 11 columns, whereas the test data, it has 418 columns and it has 10 columns. So what's the difference between the test? Let's actually this time look at to the test data. So as you can see, there is no survive, okay? So this is just the testing purposes for you to see whether you can predict properly, okay? So that's actually the result that you need to submit to Kaggle. You need to estimate whether they are survived or not at the end, okay? That's the goal. All right, so let's come back here. We'll look at the shape. Okay, so if you type sml.configure, it will give you some interesting details here. So overfit threshold. So let me put it this way. So when you're estimating a machine learning algorithm, you can come up with a really sophisticated algorithm that predicts 100% of your training data, right? We can write a gigantic if else clauses, which can predict 100% of my training data, right? I can do that, right? That's just like this crazy developer did in this for house prices, right? I can do exactly the same if else condition to predict exactly the same way. But that is called overfitting. Overfitting means you are heavily focusing on your training data. Instead, your aim is not push the 100% of the prediction of your training data. Instead, you need to come up with a really good model that predicts your test data and your future data. So that's the idea. And you need to set up your overfit threshold. If you are pushing the limits too much, then your model may not work as you expected. Okay, so that's why I prefer to set up my threshold to some number that I can tolerate. Okay, so this time the training data divided by the shape of the, actually one of them should supposed to be, oh yeah, square root of this data divided by the shape of the data. So this is a good threshold. It's not my idea, by the way. It's coming from the Andrew Ng's courses. So yeah, one of the really good feature of SML is the what was that? Estimated extraordinary data analytics. I always forget the first one, but it's data analytics. So here's the thing. SML is telling you that, hey guys, I have 1000 null features, so you need to use input function to fill these gaps. And also there are some outliers on these two areas. Possibly it's more than 3%. Those are important because if you are doing some prediction algorithm, the exceptional ones may create some false positive for you. That's why it is analyzing for you and saying that, hey, there are outliers, you need to get rid of them. This is the shape. So numerical ratio is 54%. You need to get 100% in order to use this model for mathematical formula, right? So at the end, we're going to have 100% numbers in this table. So some sections can easily be categorized. So for example, age, I can say that 0 to 10, 10 to 20, 20 to 30, right? So those are easy to categorize depending on the density. Some of them are categorical. So for example, P class, embarked, or all those things, I can put a label, right? Like actually sex is also a categorical thing. Female is 1, male is 0, right? So you can categorize that. And also you need to work on these things because they are text. You need to come up with a numerical representation of these things, and then you are going to be good. So we're not that point yet. Let's analyze some of the data to come up with our mathematical formula. So here's survived. Okay, name. We're gonna take a look at that. Sex is easy. Let's start with what was I was going to start. Yeah, age. We're gonna start with age. But before we start that, I want to show you how these functions are correlated with survive functionality, right? So there is a really good command that helps you to plot the graphic, right? So this is the correlation. The highest number means that there is a high correlation. The low blue means that there is a low correlation, right? So for example, there is a reverse correlation between the P class and also fair, whereas so these two numbers are highly correlated because parent-child number is really correlated with sibling and suppose number, right? That's why you see that there is a correlation. But I don't see any good correlation between the survived and other. So there is only one correlation with fair. That means the people who pay more have more chance to survive. And we know that from the Leonardo DiCaprio film. So that was obvious. So, but we need to analyze the data and come up with the other functions. And that's why we're going to use some of the good functionalities of SML have. Actually, these are coming from Matplotlib library, but SML has a good representation of these libraries. So this is your data look like. Your age is distributed like this. So majority of these people are between the 20 and 40 ages. Fair, majority of them paid somewhere between $0, I mean, let's say $20 to $100, I think. So this is sibling suppose number, survive distribution, P-class distribution. Of course, survive is only 0 and 1, and also this number. So we're going to analyze some of these and, take a look at them and how we can convert these things to the number that we are looking for. So first of all, remember it was saying that fair has some outliers, right? So I will write the graphic that shows us the continuous graphic of fair. As you can see, guys, it is going in this way, but how about this? It is an outlier and it can mislead you while doing the prediction algorithm. That's why you need to get rid of this one by eliminating that using the outlier formula of SML. Okay, so we get rid of, and I can run the same command right here. I don't necessarily paste again. I can write here. So this time I don't have that outliers, although there are two more outliers, but I don't think that's a good idea to get rid of that. Of course, you can decrease this number to 96 and get rid of those things, but 98 seems the good number to start with. So, and we draw the graphic, and also let's take a look at the siblings and suppose. So this is how they look like. So the number of survive people in this section, as you can see, no people survive if they have more than 4 family members, right? So that means large families tend to fail to survive rather than small families. And as you can see, if you guys have no spouse or maybe one, that's a good chance to survive. I think that's because, if I am the guy on Titanic ship, I'll probably let my wife to survive too, because I don't want to survive without her, right? So that's the idea, I think, that we're a human being. So that's a good correlation. And also let's take a look at the age. And this is actually not give us a lot of information, but at least a good idea. So if you look at the green dots are the survived ones. So they survive if you are 0 or 1 or maybe 2. But as you can see, there are no green dots at this section. So the age actually shows that if you are younger, you may not have suppose. That's a good correlation, of course, we were expecting. And also, interestingly, if you have one suppose, if you're a family with a small family, there is a chance that you can survive. So we're going to use that. And let's take a look at our estimation again. So where were we? Let's do some work and get rid of some. So outliers, we can get rid of the outliers of this one by some of the comments, but I'm not going to waste my time for that. But instead, I am going to create another feature. So let me run this. Train.head. Let's get 10 of them. So as you guys can see, age, some of them are nan. there is no data here. And also this kind of data may not be easy to analyze. You may be too overfitting your data if you are using too much precision in your data. That's why we would like to categorize the age, some density. So we're going to put another column that is going to be age density. See that last line? Okay, so it is a good approximation for me. So instead of working with this kind of data, I am going to work with this density. So in this case, this command is going to work. So I will get a better result. Yeah. So age 22 falls into 27, 38, 11. So this shows you how many 38 ages people available on this ship. Okay, so also we have the ticket section here. We cannot analyze this kind of data. We need to get a kind of a number. So what we do is the first letter of this ticket shows that there is some similarity. So what I'm going to do is I am going to get the number of tickets by looking at the number of tickets. So I will predict the ticket density. So if there are the similar tickets, then it's going to help me to find out. And there should be another feature here, ticket density. Okay, so we have that too. We can get rid of ticket because we already have the ticket density. I don't need this anymore. So I will drop this from my data. And I will also look at some of the cross relation between these two data. So please interrupt me if you have any question, because we have a lot of things to do, but I don't want to interrupt you, deal with a lot of details. So this is the relation between survive and also sibling and suppose. As you can see, 1 or 2 seems a good one again. Let's correlate them again by looking at the family size. Okay, instead of having the parch and also the siblings, I am going to sum that as a family size. In this case, I am going to have another feature which is going to be the family size. But the problem is this say family size is 0, although there is 1 obviously in this family. I need to add 1 to every family size, include the individual itself. Okay, so let's check again. Okay, so seems we're in good shape here. We have numbers here, we have numbers here, numbers here. Some of the numbers still missing. Let's get rid of them too. And what I'm going to do is I am going to drop the siblings and parts because we already correlated that to family size. As you can see, I am doing some kind of a data science in order to make my data relevant for machine learning algorithms. And I have a lot of empty spaces in the cabin. That's why I am going to, I'm going to fill the empty cabins. So let's take a look at here again. So the cabin, there are some nan. I'm going to fill them with some number with z. And I am going to, instead of using the c or these text terms, I'm going to use the regular expression to extract the first character of the data. So in this case, it is going to be the NaN data will be disappeared, and I will have a DAG section here which says this is Z cabin, this is C cabin, because I am taking the first letter of the cabin. So it's also a good representation. I can convert it to number by saying that Z is 10, C is 1, whatever, right? Okay, so that is that, and I'm going to get rid of the cabin too. So let's remove this too, and that is that. And let's see. Okay, so let's convert the female and male to some numbers because we need numbers. Male is going to be 1, female is going to be 0, and let's take a look at our data. Now remember male, female. If I run this again, I see that it's 1 and 0s, right? So and let's see. Yeah, so we have the titles and the names. I mean names here. I can drop the names, but there is some important things. While you are doing your data analysis, you need to pay attention to your data to come up with a good approximation of your machine learning algorithm. So here is there one of the important one that will help you a lot, Mr., Mrs. See that? So obviously, Miss will help you to a lot to survive, and you can draw the graphic for that, and by looking at the gender. So also you need the title, because if you are a good title, maybe a kid, and you will be have good chance to survive. That's why I will extract those parts from my data, and in this case I am going to have some title here, Mr. and Mrs. But I need to do some fine tuning because it includes a lot of, some titles. Those are not important for me. I just need some major ones. So that's why I am going to fine tune the titles by combining the MLLE to Miss, MS to Miss, Rev to Miss, MR, and MME to Miss, and also Captain, Don, Jockeyber, Lady, Major, Sir, they're going to be other, okay? Because I can't deal with a lot of titles, so because their number are not that big, so that's why I am going to remove them from my data, so it will be good to analyze. So let's take a look at the age and title. That's also a good correlation. So as you can see, Mr., they're usually couldn't survive. See that? Let me see the males. See that in Titanic, we were the people who died, okay, females? So you were survived, luckily. And also small ones like Miss, so they survived. And Master, seems that these guys are rich people. They also achieved to survive. That's the power of money. Happy to, be rich. Huh? Sorry? A young boy will be called master. Oh, yeah. That's right. Yeah. Age, yeah, that's right. Actual age is really a lot. Yeah, that's not a power of money. That's the human being. Okay, that's good. Don't need the name anymore. So that is going to be another feature elimination. So let's do again. Train dot heads and get the 10 of them. Okay, so this is how our data look like. We have numbers here, numbers here, numbers here. We can get rid of age actually. Anyway, so fair seems a lot. And also there are NaN numbers embarked again. And if you run sml.estimated data analytics or extracted data analytics, whatever, you will see a good numbers in the sum. You are 72% of approaching to all numerical representation of your data. And it's also giving you some idea and say that, hey, for age, fair, and age density, you can use the category. So feature density will be a helpful thing. And also, you can use title, embark, and DAC using the feature mapping, and then you will be good to go. So let's do the rest. I will label the embarked and all those things to numbers. So we already have C, Q, or whatever letter is that. Instead of having that letters, I can have some numerical representation of these. So it is a numerical representation of all columns now. So it seems that we're in good shape now. So we all have numerical representation. It seems now 100% ready. And if you look at the feature importance, it is also giving us some idea that sex is the most important feature, and it has almost a 30% importance to be survived, right? So that's a good one. In this case, if you look at the correlation, now you have some good correlation, right? So family size, and let me actually look at the survive. Where is it? Yeah, survive. So there's a correlation with fair again. Anyways, we will find. So here we're going to use some of the prediction algorithms that will help you to predict. So these algorithms are, I have a slide for that, but I'm not going to spend a lot of time for these things. So logical regression and the other prediction algorithm will take this model. So you already have your model in your hand, and this model will help you to predict some of the unknown data that you don't know whether they are survived or not. So this is your algorithms. That is the math running behind these scenes. So what I did is I just run the different algorithms. So for example, logical regression, we have the 80% accuracy. And for perception, we have 58 accuracy. For Ken neighborhood, we have 75, 71. And all those things, we have different approximations. So depending on your data and depending on your model, you may have different algorithms that work for you. So there is no one solution that works for all machine learning problems. So it depends. I mean, this is the Titanic problem. Depending on your approach, maybe a logical regression will work for you best. But if you're a kind of a guy tend to solve the problem with decision tree problems, that's another approach. So you need to pay attention to optimize these things. So for example, I just tried to do my best to optimize all these algorithms, and it seems that I did my best with extracted tree, extra tree classifier. So I have 83% accuracy of these algorithms, and then by using that, I can predict 83% accuracy with respect to the other one. So let me scroll down a little bit and see that how good they are when I, after the fine tuning. So extra tree with this model that we have generated can predict the test data with 87%, and gradient boosting can predict you 82%, and as you can see, perception is the worst one. So at this point, you can choose that, hey, extra tree seems the best solution for me. I can use that to predict my future events. That might be your solution, but there is another catch point at this stage. So instead of just choosing one algorithm, you may choose a voting algorithm. So for example, you can take a look at the data and find out which one is thinking that which parameter is the most important one. So as you can see, sex is almost the most important parameter for all algorithms, right? So you can also use a voting classifier. This is actually a classifier for your machine learning algorithms. There are multiple algorithms generating some data, and this voting algorithm can get some weights to predict the accuracy of your algorithm and come up with an entirely different approach to your prediction algorithm. So, and I use that actually to predict that, and I get an average of 80 to 84% accuracy to predict my data. Okay? So, in this case, is it a good result or a bad result? You don't know. It's not 100%, so do you think I should work on it a little bit more and come up with a better approach? You still don't know. You need to cross-validation to find out whether this is the right thing to do or not. So at this point, my idea is save these findings to some text file. I just saved it to meetup.csv file. I submit it to Kaggle and see that whether I'm doing a good job or not. So at this point, actually, let me see my submissions. I just submitted a few 3 hours ago. So I get a 76% accuracy of unknown data. Okay, so that is a good point. Good starting point. 76% is a kind of a good approach, but there are some still mistakes that needs to be fixed. So I want to ask these questions to you guys. Well, in our data, there were some non-data, remember, and especially in cabin. We just say that for cabin, just let's use Z for all cabins. That's a horrible mistake. You cannot just assume that all that people are in the same cabin. There's no way to do that, right? There's no possible way to be happen. So you need to come up with a better approach and say that, hey, my cabin probably cross-related with the ticket number, right? Because depending on your ticket, probably you were in some cabin, right? By looking at the other tickets, you can estimate the cabin number. And also by looking at the siblings and parents, right? If I am in some cabin, probably my parents are in the same cabin, right? If you know me that I am in that cabin, you can also come up with that number. So that's also one thing that we need to fix. And the other one is we just assume that the, what was that? The embarked, some of them are unknown. Embarked, unknown means that they died. We don't know. So if they died, it doesn't mean that there was an embarked. Anybody in this embark, we're gonna kill them. Sorry guys, that stands for to killed people. If you would like to be in that embark, you're gonna die. That's not the problem. That's a wrong approximation, right? So that is we need to approach that. If the people in some DAC, they were in some embark, probably some people would supposed to be same embark, right? If I am in C and I am in the same DAC with this guy, probably he is supposed to be in the same DAG tube or embark tube. So those are the fine tuning that you need to adjust. So in that case, you will have better mathematical representation of your data. In that case, those algorithm, logical regression, random forest, or extra tree classifiers can predict your algorithm in a better way. So this is the, at least a good starting point to find out what my data will look like, or maybe the how my prediction look like. But the idea is analyze your data, come up with some assumption to convert your text data to some numerical representations, and fill the NaN data to some data which makes sense. And then when you have some letters or labels, convert them to number representation. If male is 1, then female is 0, just like that, okay? And then you can come up with the all numbers, and we can use this for other algorithms to predict whether they are going to survive or not. So this notebook is available in the titanic.zip file. So I'm going to stop here. In the next part, we're going to do a little bit, I'm not going to explain the whole code details in the next section, but I'm going to explain you how we can predict a face